on the 4850. One of the things that I always like to tell people, and this isn't just for industry or mining, but I urge you to think about these things wherever you go, into a building, into a facility, is to know how you got here and how to get out of here if something bad happens. Okay, our primary exit are out these two doors, and our primary gathering place, if we need to exit the facility, would be up the stairs. Don't take the elevator. And if you're not able to go up the stairs, we'll go out the back door and meet out at the, right outside the double doors, right here to the south. But the primary gathering point for West Hills Village is the main parking lot. We want to keep track of everyone is here. So this sign-in business, we want everybody to sign in that they're here. Also acts as a way of keeping track of who's here, even if something bad happens. As well as for Bethany and Aaron to see how well things are attended and what they can do to continue to improve our facility. So with that, does anybody know where their nearest fire extinguisher is? Raise your hand if you think you know where it is. Okay. It's right outside this door I'm looking at. Okay. And I gotta tell you, as I was setting up for this, I thought, oh, I gotta look for where's the nearest fire extinguisher? I walked right by it. I could not, I said, this can't be, there's gotta be one close by. The next nearest one that I found was on the south side of the dining room up on the 4th floor. And but there it is. And does anyone know what an AED is? Automatic, electronic, or automatic defibrillator, okay? Anybody know where that's at? Yeah, that's right outside the door. So we've talked about our primary and secondary egress. We've talked about fire extinguishers. We've talked about AEDs. There is water just out these doors and to the west, or your right as you go out. There's a drinking fountain there, there's coffee, there's tea, and there's lots of restrooms off to that hallway. Now, the other thing I want to do is I want to thank everybody here. This is Labor Day, and I think it's really quite appropriate that we're talking about something that deals with labor. And let me tell you, there's a lot of labor involved in mining and maintenance and construction and all of those other entities that provide everything that we have. As I said the last time, if it can't be grown, it has to be mined. And that speaks not only to our minerals and all of the other amenities that we have, but also our friendship and our families. We have to mine that. We have to cultivate that, as it were. So on this Labor Day, I took the liberty of writing a poem. One of my things I always wanted to do in my retirement years is write. So I write essays, and I'm writing several books, and I write all kinds of stuff. And poetry is one of the things I like. My poetry is not iambic pentameter for you English teachers. It's more free floating type poetry. So here it is. The work beneath our days. Labor Day for the Home State Mine presentation, September 1st, 2025. We gather not to punch the clock, but to remember what we gave. The hands that shaped both stone and stock, the hearts that labored long and brave. Not only miners carved the way, but teachers lit the minds of youth, and nurses held the night at bay with quiet strength and tender truth. The farmers rose before the sun, the builders raised the beams with care. The clerks and cooks, each task begun became a thread in labor's prayer. The Homestake mine ran deep with gold, but deeper still the lives it fed, and all who worked, both young and old, now walk where memory dares to tread. You, who shaped this nation's soil, with wrenches, pens, healing hands, your legacy is not a goal, but something time still understands. This Labor Day we honor you, not just for toil, but for the grace of building something good and true in every hour, every place. So let the mine be more than stone, and let your stories rise and shine, a monument of work well done, etched in the seams of sacred time. So with that, see if I can do this without blowing us out of the water, literally.
That's okay, we know where the fire extinguishers are.
Good man. Oh, okay. Right. I'm looking for it. These eyes don't work like they used to. All right, here we go. I'm going to be showing a series of videos, some a little longer than others, and I'm also going to do a slideshow, a PowerPoint presentation, and have a little time for discussion. And when we finish, hopefully we'll have some time for some question and answers. By the way, I want to introduce a couple of people. My granddaughter, my wife, Diana, and my brother, who came down to keep me honest. Between Dan and I, we have well over 100 years of time at the Homestake mine site. So, yeah, that's phenomenal. Thanks for being here, Dan. Anyway, this first video is a short little video that's actually on the Sanford Lab website, talking about what is SURF, Sanford Underground Research Facility, at the former Homestake mine. It's a short little quip, but it's a good way to kind of get us ready to go.
The Sanford Underground Research Facility, or SURF, is America's deep underground science laboratory. Our mission is to advance world-class science and inspire learning across generations. SURF hosts cutting-edge research in multiple disciplines, including physics, geology, biology, engineering, and more. Work at SURF is contributing to the fundamental understanding of our universe, advancing our nation's energy independence, exploring life in extreme environments, and providing basic research that is the foundation for ongoing technological advancement around the world. SURF's collaborators include over 2,000 scientists from more than 200 national laboratories, institutions, and universities worldwide. SURF also plays a vital role in inspiring the next generation of STEM professionals with a robust education and outreach program that reaches nearly 20,000 students and 400 teachers annually. SURF is generating a $2 billion economic impact on South Dakota this decade alone, with the potential to create 1,200 jobs across the state. We are proud of our history, which includes Nobel Prize-winning research on this site, and we have a bright future with ongoing and planned experiments that will continue to inspire and push the boundaries of human knowledge for decades to come.
All right. As a new employee, we want to introduce you to the values of what the Sanford Underground Research Facility stands for. And one of those primary values is taking care of people, of course, and also the environment. And that environment includes not only the land and the air and the water, but also the cultural environment that we live in the sacred Black Hills, the Pahasapa. And I've been part of that, as Deanne has, for really our whole lives, having grown up in Lead and Deadwood and married gold miners' daughters. And although our father did not work at the mine, he provided services for the residents in the Black Hills as part of his contribution. So we're kind of the first and the last, if you will. And I always like to remind myself and others that we have extracted over 44 million ounces of gold from these sacred hills. And when the mine closed and started to close in 2000 and through 2003 as we did the cleanup closure, and then allowed the pumps to be turned off and the mine to start flooding, there was still a core group of people that really had a burning desire and a vision, if you will, to repurpose the mine for education and science. And a lot of people worked very hard in those early years to do that, because we felt like this is our generation to give back. And we're still mining. We're doing a lot of mining. But we're not mining minerals. We're mining education. We're mining outreach. We're mining community. And that's what this video is about.
At Sanford Lab, we've worked with regional tribes and federal and local governments to ensure our current operations and future projects are sensitive to the region's cultural heritage. We respect the heritage of the region and in our daily work make every effort to ensure our impacts on the land are minimized. While planning for the Long Baseline Neutrino Facility and the Deep Underground Neutrino Experiment Project, we incorporated this philosophy through a formal environmental assessment and programmatic agreement addressing cultural issues. These documents lay the groundwork for how this project will be completed in a way that's respectful of the cultural and historic significance of the region. These documents are available for review if you'd like more information.
When Barrick Gold Corporation donated the Homestake Mine in 2006 to the state of South Dakota, the facility gained a new purpose.
For over 100 years, many people and cultures have found their way to the Black Hills to mine primarily for gold. Today, scientists come from all over the world to conduct world-class research at the Sanford Lab. For thousands of years, many Native American tribes called the Black Hills their home. For the Lakota people, we refer to the Black Hills as Hesapa or Pahasapa. And this area provided all that we needed to sustain life. It provided a way of life that we understood, and it also helped us to have a close connection to these sacred lands. And it also helped us to better understand our place in the universe. If you look at the Black Hills from an aerial photograph, you will see that it's shaped like a human heart. That is why we as Lakota people refer to the Black Hills as the heart of all that is. It is the center of our universe. It is a sacred place. When we did come to the Black Hills, we only took what we needed. In 1868, the Port Laramie Treaty was signed by the Lakota people and the United States government, promising this land forever. In the 1870s, gold was discovered, and this was really a and the great intrusion to the Lakota people and other tribes that were here. The people after this were relegated to reservation life. They had to move from these vast areas of land which they had lived on for centuries, and their way of life drastically changed.
The Black Hills are culturally significant to American Indians. At Sanford Lab, we believe it is important to honor this, and as we move forward, we pledge to approach our work in a respectful manner. The facility is ideal for research that can answer fundamental questions about the universe and our very existence. The groundwork to create this underground research facility was laid during 125 years of mining. By taking advantage of the existing shafts, caverns, and infrastructure, we have a minimal impact on the land.
Research is important, and for us to have a better understanding of the world, but also to have a better understanding between cultures and between people. And so many Lakota people have started rethinking about the Sanford Lab as being a positive addition, because we can see that connection between the stars and the universe and the research that is being done at the lab. A renowned scientist, Carl Sagan, once said that we are made of star stuff. Well, Native American tribes have known this for centuries. We know that humans come from the stars. We're connected to the stars. In fact, everything is connected. Everything in the circle of life is connected. Mitakuye Oyasi. We are all connected. We are all relatives.
At Sanford Lab, we strive to be good stewards of the land.
The deep underground neutrino experiment will require the removal of 875,000 tons of rock.
Because this land is so sacred to many tribes, the rock will not be removed from the Black Hills. We also make every effort to preserve artifacts found during construction or excavation on Sanford Lab property and completing projects with minimal impact to the environment, including native plants. Future plans include developing an ethnobotanical garden for culturally significant plant species. The space will provide an area in which selected species can grow and where people can learn about how the plants are used firsthand. Whatever your role at Sanford Lab, we ask you to approach every aspect of your work with respect for the cultural diversity and the rich history of the region, and of course the land itself. The significance of the Black Hills to American Indian nations is not merely historic. The land remains a cultural and spiritual landmark to many Great Plains tribes today. Many visitors to the hills find that when they leave, they've established a special connection to the area. What might yours be?
All right, that's the beginning, and that sets the foundation for our trip underground. But before we go underground, you have the right and responsibility to know what your limitations are and what you need to do and what you need not to do. So we've developed over time safety videos and safety training for guests and employees to go underground. And the video that I'm going to show you is actually one that we produced in 2011 when we were just getting the 4850 developed for science. And I chose this one for a couple of reasons. First of all, to give you a sense of what it kind of looks like before you start developing large science areas, and a sense of what it's like and looks like underground, and because I'm in it. I thought it would be kind of fun to show you what I did and how I did things. But it's a pretty good video, if I do say so. We had a lot of fun making it, and afterwards I'll show you a couple of outtakes. So I'm willing to embarrass myself. So this video is going to give you the basics of what it takes to go underground and to be on the home stake site.
Welcome to the Sanford Underground Laboratory at Homestead. I'm Jim Tarpinian, Environmental Health and Safety Director for the lab, and this is our emergency response team training facility. Members of the team are highly trained professionals, but everyone at Sanford Lab gets safety training, including visitors. In this video, you'll learn some basic safety procedures from two experts. Health and Safety Manager Brendan Matthew will take you on a surface tour. Operations Safety Officer Ralph Rosene will take you underground. But first, let's cover some policies, procedures, and principles that apply to the entire facility. For example, as a visitor, you have certain rights and responsibilities.
That's right, Jim. As a visitor, you have the right to a safe environment, information and proper training that you'll need for a safe visit, and safety equipment that is appropriate to your situation. And like everybody at Sanford Laboratory, you have the right and the obligation to stop work if you encounter a situation that you feel is unsafe.
You also have other responsibilities. You must agree to follow all Sanford Lab safety procedures, obey all safety signs and staff instructions regarding safety, and take responsibility for your own safety. Be aware of the environment around you. Thanks, Tom. And remember, our most important mission is your personal safety. So if you see anything that does not look right or you believe is unsafe, please report it immediately. And now, let's look at specific safety procedures for visitors at our surface and underground campuses.
The Sanford Lab Surface Campus is 186 acres. It includes more than a dozen buildings. Sites you may visit include the Yates Administration Building, the Yates Education Building, the Ross and Yates Shaft head frames, the Surface Laboratory, and the wastewater treatment plant. All buildings at the Sanford Lab are equipped with first aid stations, fire alarms, and fire extinguishers. Every building is also equipped with emergency exits. Sanford Lab personnel will point these locations out to you when you visit each building. The visitors begin at the Yates Administration Building, so let's take a closer look there first. Use the main entrance on the west side of the building. You'll check in here. You will need a photo ID. You'll receive safety pamphlets and a visitor's badge. Please keep the badge with you throughout your visit to the Sanford Lab. Turn it in when you check out at the end of your visit. In the Yates Administration Building, there are clearly marked exits on the south and east sides of the first and second floors. There are also first aid stations on both levels. In case of evacuation, exit through the main door on the west side of the building if possible. Assemble on the sidewalk across the street. This is also the assembly point for the Yates Education Building. You'll need an escort for most other sites on our campus, and you may need personal protective equipment or PPE. So let's take a moment to talk about PPE. PPE may include hard hats, safety glasses, reflective vests, adequate footwear, and ear protection. Sanford Lab is a construction site, so expect to see heavy equipment on the move, including trucks, forklifts, and loaders. Listen for backup whistles. Make eye contact with heavy equipment operators before you approach machinery. You may also encounter routine traffic, including pickups, large trucks, and passenger vehicles. Roads, yards, sidewalks, and pathways at the Sanford Lab include blind corners, sharp curves, hidden entrances and exits. You also could encounter steep banks and walls. Remember, the speed limit is 10 miles per hour on the Sanford Lab campus unless otherwise posted. Also remember that the speed limit throughout the city of Lead is 20 miles per hour, and it is strictly enforced. Some access roads to the Sanford Lab are in residential neighborhoods. Please be on the lookout for local traffic and pedestrians, especially children. While walking, always be alert to the dangers of slips, trips, and falls. Watch for wet, snowy, or icy surfaces, and loose gravel, especially on steep grades. Watch your step on uneven surfaces. In construction zones, you could encounter cords, hoses, building supplies, or other hazards. And don't forget to look up for hazards, such as suspended loads or overhead ropes. Special training, equipment, and authorization are required for entry into confined space areas, for the use of ladders, and for areas where fall protection is required. Access is restricted in some areas of our surface campus. Please watch for signs restricting access to buildings or to other areas on our surface campus. Restricted areas can include electrical substations, rooms where equipment is running, or even to entire buildings. Sanford Lab personnel will provide you with all the additional information, training, and protective equipment you will need for a safe visit to the Sanford Laboratory. If you have any questions concerning hazards, procedures, safety equipment, or any other safety issue, please ask any member of our staff. And remember, if you encounter any situation you feel represents a hazard, notify us immediately. Our most important goal is your safety.
Before we begin our safety orientation, let's look at our underground geography. The lab is 8,000 feet deep. There are 370 miles of tunnels and ramps. The two main shafts, the Ross and the Yates, give us access to the 4850-foot level, which is the main underground campus of the Sanford Laboratory. There's a lot of territory underground, 7,700 acres. But don't worry, you'll have experienced guides wherever you go. In this video, I'll explain a number of safety systems and procedures, including locations of escapeways and secondary egress, where to find first aid stations and other emergency supplies, how to use communication systems underground, what to do in case of fire or other emergencies. To make these safety procedures easier to remember, I'm going to take you on a quick tour of the 4850 level, but first we need personal protective equipment, or PPE. You'll need a hard hat, safety glasses with side shields, reflective clothing. You'll need a pair of hard-toed boots. You're also going to need a self-rescuer, which I'll explain a little bit later. And finally, you're going to need a cap lamp. So let's go get one. This is a lamp rack. You'll be issued a cap lamp like this one with a battery and a lamp. The lamp attaches to your cap on this bracket. The cord attaches to a strap in the back that snaps together. The battery will go on a utility belt like I have, or in a backpack, which will be provided. To turn the lamp on, turn the switch. Now we're ready to head down the ramp to the Ross shaft. Before we go underground, we'll need to tag in on this board so that we know who's underground at all times. You'll be assigned 2 brass tags like these. Write your name and tag number on the sheet. One tag will go in your pocket. The other tag will hang on the inboard.
When you return to the circle, tag out. Return both tags to the outboard and sign out. Your guide will remind you how to do that. To get to the 4850 level, we'll ride this elevator car called a cage. Watch your step getting in. Our ride to the 4850 level will take about 10 minutes. Cage coming up off chairs.
Cage coming up here.
Stop cage.
Cage stop.
Cage 4850.
Cage 4850.
Lower cage. This cage can carry up to 8,000 pounds. Cables, hoists, and shafts are inspected regularly to ensure safe operation. In an emergency, safety mechanisms can stop the cage anywhere in the shaft. Welcome to the station at the 4850 level. Our biggest safety hazards are slips, trips, and falls. For example, this is a rail stop used to prevent rail cars from entering the shaft. It's also a tripping hazard. When you exit the cage, move past this sign. On any station, remain a safe distance from the shaft. Let's talk about communications. In the shaft and on the station, we can use radios to communicate with the surface. We can also communicate with the surface using femto telephones. To operate, lift off the receiver, push this button, identify yourself and where you are. Housekeeping is an important safety practice on any construction site, especially underground. Please use our trash receptacles. And remember, avoid slips, trips, and falls. We also have emergency and first aid supplies underground, including eye wash stations, fire extinguishers, defibrillators, stretchers, and first aid kits. And yes, we do have toilets underground. Maps are posted at stations at every level. This map of the 4850 shows us where we are, the Ross Shaft, which is our primary escapeway. The map also shows us how to get to our secondary escapeway, the Yates Shaft. Your tour could include a ride in a personnel car. Watch your step getting in. Keep your hands, feet, and equipment inside the car at all times. The locomotive operator will sound the horn before moving. Be careful getting off, too. We monitor underground air quality in several ways. In some areas, your guide will carry a handheld monitor like this one, which measures several types of gases, including carbon monoxide. Homestake was never a gassy mine, but underground fires can release carbon monoxide, an odorless, colorless gas that can be deadly. Permanently installed carbon monoxide sensors like this one sound alarms on the surface if CO levels rise. Fresh air flows down the Yates shaft and the Ross shaft. Doors like this one control the flow underground. Wherever you go, you'll always have fresh air. Now that we've talked about ventilation, let's talk about the W65 self-rescuer that you'll carry underground. self-rescuer will protect you from carbon monoxide that can be generated by a fire. It will not produce oxygen. It's a filter respirator. It will protect you for 1 hour. Here's how it works. We'll pull the pin, pull straight out, let all the hardware drop to the ground. Pull off the top cover, let it drop to the ground. Take out the neck strap, make sure the nose clip is out front. Give the neck strap a couple of twists and pull straight out. Let the bottom canister drop to the ground. Take your hard hat off, put your safety glasses inside, put between your knees. Put the head strap on, bite down on the mouthpiece and put the nose clip on. The mouthpiece might get hot, but that means it's working. Don't take it out until you get to the surface. Now let's go look at some other areas of the 4850 level. You might visit underground rooms like this laboratory. It's well lit. It's clean. The floor is concrete. The ceiling and the walls are shot treated. There's even a telephone that you can use to call anywhere in the world. But in some areas of the Sanford lab, you will need your cap lamp. Again, we want to stress that slips, trips, and falls are the most common hazards underground, especially in unlit areas. Be aware of wet, slippery, or uneven ground. Watch for railroad tracks and ditches. Be aware of the environment overhead, including utilities such as pipes and cables. Treat all cables as if they were live. Do not touch them. Engineering controls like rock bolts, steel mats, and mesh keep us safe underground. And the areas you visit will have been inspected before you arrive, but you should be aware of your environment too. Look up. Look down. Look all around. And always watch your step. And take your time. We're never in a hurry underground. Also, remember that the Sanford Laboratory is a construction site. Whether you're underground or on the surface, watch for mobile equipment. Stay clear of moving trains, motors, or other machinery. You can use your cap lamp to signal equipment operators or anyone else underground. If I shake my light back and forth, that means stop. If I move my light up and down, that means go away from me, go away from me. If I circle my light, that means come here, come here. I'll end your safety orientation with 2 important rules. First, stay with your guides at all times. They will know where to assemble in case of an emergency and how to communicate with the surface. Second, remember that wherever you are underground, there are always 2 escape ways. White reflectors mark your primary escape way. Blue reflectors mark your secondary escape way. Thank you for your attention. Safety is our most important mission. If you see, hear, or smell anything that might be a hazard, please report it to Sanford Lab personnel. To go underground, you'll need a hard hat, safety glasses with side shields, reflective clothing, hard-toed boots. You'll also need a self-rescuer, which I'll explain a little bit later. To go underground, you also need a cap lamp. So let's go get one. Need a cap lamp, so let's go get one. You know, I was in the military. Let's talk about communication.
There you go. An actor wannabe. All right, well, we've reached the point now to where we're ready to go underground. It takes a while. We're almost 45 minutes into it, and we haven't even left the surface yet. So let's get going and get this to work. Okay. Before we go underground, just like before you fly in an airplane or ride in a bus, there's a manifest that has to be made out. And we call them a trip action plan. And it is the planning that goes ahead of the time before we take people underground so we can keep track of them. And we can talk about the hazards that we might encounter on the way. This is what a trip action plan looks like. Shows who the people are. This trip is actually one that I took on July 2nd, 2024 at 6 o'clock in the evening. We went underground, and 3 of us are all in the mine rescue team. So we did our discussions with our supervisors and department heads and other crews, including TMI, which was the prime contractor for the construction work at the time, and the Ross Shaft crew. So everyone was aware, and we knew any changes that had to be encountered and dealt with as we went. So okay, well, so this is us underground. This is the 2 mine rescue guys that we all went together, Dennis and Paul. And this, there, you can see them standing next to this piece of heavy equipment. So, and in the background you can see this sign, and that's what I'm standing next to. That is the dedication sign that was done very early on when the site was dedicated to be a deep underground science and engineering laboratory at the former Homestake mine. And dignitaries from the legislation were here, the board of directors, and this plaque was installed at that time. This is the documentation. We call it a toolbox talk. It talks about what could happen, what could go wrong, and how do we prevent any incidents, injuries, environmental impacts, interruptions to production, any of those types of things. So we plan that all ahead, we sign it, we have our supervisor sign that before we go underground. So we're going to go now from the Ross Tramp top down that ramp, and then we're going to go up above the ramp to what's called the landing, which is actually the surface. The ramp is 1 story below, and give you a little short tour of the crusher room. So this series of slides takes us, and I'm going to use this pointer, and there's a story behind this stick. I'll tell you what that is later. No, it's not to beat people. But anyway, this is the ramp. Walk down this long hallway. This is the current brass in, brass out board. From 2011, the number of employees has really gone up exponentially. And in the height of construction, there's going to be close to 400 or more construction workers, not all at once, but working 24 hours, 7 days a week. So to manage that is a logistics. There's got to be some skilled people to think about how to do that, okay? Kind of like airports. And we'll talk about that at another time. On the ramp, behind the cage, so this is the ramp area. These are the 3 compartments that have the conveyances in them. One is the cage compartment. It's going to have a double deck cage in it pretty soon. Right now it's that single deck cage, which is about 4.5 feet wide and about 12 feet, a little over 12 feet, 2 inches long. And so it's a small elevator, not much bigger than our main floor elevator. And in the height of production, we used to put 32 people in there, 4 in a row, and you were pretty close to your partner. And you know, the amazing thing is, there was never any horseplay. Not one time. Dan called me on that one. He said, that's not right. You're that close. You're like this. Your lunch bucket between your knees. And yeah, it's cozy. Not pandemic stuff. But behind this shaft, there's more compartments, utility compartments. And this is the little hallway that goes there. And in that little hallway, to get to the back of the shaft, is this system right here. And that system is called a stench system. We can automatically dump ethyl mercaptan into the ventilation system to get what we call stench. It's basically the same smell that you smell in your gas stove to your house. It's that smell, kind of, some people say like rotten cabbage smell. At any rate, if people can smell that, they know that they need to go to their primary escape route or the nearest telephone and find out if they should go to primary or secondary. So in addition to many other methods of signaling, we can also do it by the sense of smell. And it can also be dumped manually. So we're getting ready to go underground. Paul's standing here waiting for the cager to come get us. If in the unlikely event that we can't get up the person carrier, the cage, elevator cage, we could ride on top of one of the other conveyances, which were skips that brought rock up, but there's a platform on top, but no railing around it. And you need a little training, and you need fall protection, a full body harness. So we have these tubs of full body harness all over on all of the levels that we take people to, and we, if we need to, the guides can get people up. I think we can take up to 6 people at a time, so it would take a little bit to get a group like this up to the surface, but we could do it through any of these conveyances. And we have the same number of conveyances at the Yates, so if we can't get up at the Ross, we can go up at the Yates. And that one has also has some extra self-rescuers in it. This is a little busy, but it's a top-down view of the facility. So this is where the cage is at, below the top. This is where we were standing, and this is the hallway that I told you about, the stench system. And this is the crusher room. So this is the head frame, you might say. So the shiv wheels are way up here. This is the crusher room areas. All of this is. And this is the offices and facilities for the cagers in that little section there. It's a pretty big building. And this is what it looks like up on that landing. You can see the cage. Now in this picture, there is the double deck cage. They're replacing it very soon. They took this out for some of the construction work, put one in. Now they're getting even a fancier cage that maybe we'll talk about it another time. But this is what we ride in to go down, and these are the skip compartments. This is the crusher room as you walk in, some of the operating equipment. Looking over the main crusher floor, it's actually several stories high. That head frame is 150 feet high. And the rock goes down through a series of crushers when they're excavating. Next, we're going to go to the 4850 to the Ross station. We're going to take a quick stop at the refuge chamber. So we have in various places underground not only primary and secondary escape ways, but we have a refuge chambers on many different levels. Particularly the 4850, where most of the work is going to be done. The current refuge chamber will hold up to 140 people for 96 hours. With all the amenities, toilet facilities, food, water, bedding, self-contained electrical system, self-contained recirculation air system to scrub the air of carbon dioxide, air conditioning. So if in the unlikely event, we have that third option. And then we're going to go over to what's called the long baseline neutrino facility. So the big project that they're building is called DUNE, Deep Underground Neutrino Experiment. And we'll talk about that a little bit more next month. But the Homestake site, SURF, is going to be the receptor for the neutrinos that are going to be made, not by stars, but by a cyclotron atom smasher, and those neutrinos will go through the Earth about 850 miles to the lead site. Basically, it's going to be like a big swimming pool, okay? But it's not water. So this is a top-down view of the 4850 level. The Ross shaft is right here. The refuge chamber is this area right in here. All of this. These are science areas. This whole area is the long baseline neutrino facility. The Yates shaft is up this drift. This is, if you can get a little sense of size, this is a 14-foot by 14-foot tunnel called a drift. This is a 9 by 9. And then there's lots of other areas on the 4850. It's a gigantic level. It goes out to the southwest and it goes out to the southeast. We'll take some tours there one of these days as well. Again, this is a little bit more view of it. This gives you an overview of the area. Here's the Yates and the Davis campus where there is current science going on right now. And that's where Dr. Ray Davis received the Nobel Prize for his chlorine experiment for the affirmation of neutrinos. And this is the DUNE long baseline neutrino facility, and that's an area to the southwest. So this is when we're getting off the cage here. And you can see this is that Ross station. Remember when I got off the cage in that safety video and I told you about the rail stop that could be a trip? This is the same place, but it's been refurbished, reconstructed. And instead of being a 9-foot high ceiling, this one, each one of these sets is 16 feet high. A huge open area. And we'll talk a little bit more about that, but that's called the brow, just like your forehead is a brow. And that's to give enough room for large pieces of equipment to come down the shaft and be swung out onto the level. Some up to 40 feet long beams. Yes.
So when they get these machines on, how are they bringing it down the tunnel?
There is, once they get it to the 4850, there are overhead beams, overhead cranes that will pick them up and take them all the way over to where they have to be constructed, lower them down, and they'll be building these big tanks. Good question. All right, so this is the Ross station. This is behind the Ross, or the back side of it. There's blast doors all around the shaft area, so during construction, when they were drilling, blasting, loading, hauling, and dumping, the little over 850,000 tons of rock to make this space in the last 2.5 years, they had to close off to protect the shaft and other working areas. So there's blast doors there. This is us walking down the tunnel to get to the LBNF. These are toilets. We're in the process of putting in flush toilets now in this area. They just let the contract, as a matter of fact. And so this is the looking east from the station. We'll take a break here and go to the refuge chamber. Again, lots of training. That's what this slide says. You got to be trained in it. But your guide is trained in it. They know how to operate it. I should put this slide up just to give you an idea of all of the facility safety equipment that's around. Each one of those represent either a fire extinguisher. These are air doors. This shows the which way the air is flowing. There's AEDs, first aid kits, telephones. So on your map, you will be given, you'll know where all of those things are if you need it. This is the refuge chamber, and I won't go into great detail, but that's what's called a scrubber. We've since upgraded the system to be even more efficient, but that's what takes out the carbon dioxide. So as we're all exhaling here, hopefully the HVAC system is recirculating air, or we're all going to get really, really sleepy. Okay? That's what we exhale, is carbon dioxide, not to be confused with monoxide. As we go back, we walk back past a couple of 8-ton electric locomotives. My brother, by the way, was a supervisor for all of the electrical equipment at Homestake at one time, at least the DC electrical equipment. And so that's the 8-ton electric locomotive. There's 2 of them there. Just a little bit beyond here is this blast door and ventilation door, and then you walk out into that big open area, and the reason it's blue is because of the I call them Christmas lights. It's those LED lights. They're hung up all over the place, and with the camera it picks up the blue light from them. So again, here's the facility to give you a little bit more of an idea of it close up. The little arrows show which way the air is flowing and ventilation. Right now, this shows the air going this way, but once they get this going, this air will switch and this will be an exhaust. That's a 14-foot diameter borehole at the end of that, which is a raised, basically a cylinder hole in the ground. It goes from 4850 up to the 3650 level. Then it takes a little hop over to a ventilation shaft that takes the exhaust air up from the 3650 up to the surface, called the Orohondo shaft. But you can see these 3 big caverns, and I think I have a map with the sizes of them. So again, this gets a little bit more detailed. You can see all of this grid work. Those are the tanks that the steel beams that will hold the tanks that will hold liquid argon. That's what they're going to shoot the neutrinos at, is the liquid argon. Liquid argon is a noble gas. It's a gas just kind of like nitrogen. You know, the air that we're breathing right now has about 21% oxygen and about 78% nitrogen. It's a well-known Plentiful gas. We breathe it all the time. Those rebreathers that the mine rescue team wears scrubs out nitrogen or facilitate the removal of nitrogen as you're exhaling. Again, another story for another time. But these big tanks will hold liquid argon. And I'm not going to go into the details on that, but how do you get tens of thousands of gallons of liquid argon that has to be cooled below 400 degrees Fahrenheit, below zero? And they got it figured out. I kind of understand it enough to just say enough what I think I know. At any rate, the center cavern is where all of the utilities are at and the experiment space, and so it's going to be a very busy place. And let's see, does this map have the sizes on it? Oh, well, yeah, kind of. So these caverns are 65 feet wide. These outside ones are 90 feet high and 500 feet long. This one is not as deep. So these two caverns go down to, I think, the 4,900 foot level. So below the 4,850 foot level. And with an arch back, a rounded back. And this cavern is, I believe, 650 feet long. And then this is where the water is, there's always water coming in. So they have to pump water, not a lot, but enough to where they have to deal with it. And there's always water in use. And that's where they collect the water, and this is where that 14-foot Oro Hondo exhaust borehole is at. Again, four detectors eventually. And if you drive down toward Family Fair, there's a building with a big warehouse yard behind it, and you'll see all these red beams laying there. Those are the beams that will go here. I believe they were manufactured in Spain, brought over by ship to a place on Gulf of Mexico, Gulf of the United States of America, offloaded, transported by rail to Rapid City, offloaded, and they'll be coming up daily to lead by road, by truck. So this is one of the caverns, and it's really difficult to get a sense of how gigantic they are. The first time I walked into them after they were constructed, and I walked out from the small drift off to the side, and it gave me almost a sense of vertigo. It's like, wow, that's 90 feet high, that's 500 feet long, that's 65 feet wide. They're huge. And you can kind of see this is probably close to 6 feet high here, and a person standing pretty close. And again, I made this series of photographs, had the guys give me photograph me wearing my respirator. This is actually a road, a ramp that goes down from the 4850 to the bottom of that chamber to get to it. And once you walk out, again, trying to give a sense of how high it is. And this is the 4850 foot level, and this is the bottom of that chamber. And in that ramp around the corner, they haven't yet put in some of the ventilation doors that we talked about, but they needed to control the flow of air, so they're using basically parachutes for temporary air stoppage. And again, gives you a sense of the size of that. Now we're back up on the 4850. We're going to look off the mezzanine into the bottom of the chamber. And some of the equipment that's in the area. And this is back on the main line. So this is about a 10 by 10, maybe 12 by 12 size drift on the west side of the facility. Now we're headed to where that borehole is at on the bottom again. And this is one of the air doors that are in place. You can see there's a walk-through door, and those doors are hydraulically controlled. It can be opened and closed to get equipment in there. The access from the top, looking down, and this is looking at the very back part. These are the cement holding dams for water and processing areas for the water. And then right in the back is that 14-foot diameter borehole to the 3650. And on the very east end, as you come out of the big drift areas, it narrows back down to the 9 by 9 drift, goes around the corner, and looking south, now this one's looking north, I guess this one's looking south. But you can see the drifts. This is kind of the older area, less maintained, not needed for science yet. So we have to go in and inspect those from time to time, but that's looking way south. That's probably a mile south. There's a whole nother huge mining area that is abandoned. And it's closed off with an air door a little ways down the track line. So that's it. Again, SURF's vision is the world's preferred location for underground science and education. We advance world-class science and inspire learning across generations. The world's preferred location for underground science and education. All right. I've gone over by about 10 minutes. I actually do have another video. If you want to stay, I'll stay. For those of you who've had enough, okay. The next video is actually one that was produced by SURF just this last July on Neutrino Day. It's a little over an hour long. We're not going to watch all of it. I've got about 10 minutes that if you want to watch it, it's the current construction workers that are getting ready to install all of those beams and the science project itself. And after that, they had a question and answer. It was a live broadcast to people on the surface that could communicate with those underground.